Hello everyone, I am Goel, faculty in the Department of Electronics and Communication Engineering of AKGEC Engineering College. Welcome all of you in the video lectures of the subject Communication Engineering, subject code KEC 401. This is the syllabus of the subject Communication Engineering that I will be going to cover in my video lectures. This is the syllabus as per AKGEC scheme. The complete syllabus of the subject Communication Engineering is divided in 5 units. In the very first unit, that is the review of signal and system, frequency domain representation of signals, principle of amplitude modulation systems, that includes DSB, SSB and VSB modulations. Under this unit, we will discuss and understand about the basic concepts of communication engineering. What communication is all about. To understand the concept of basics of communication, we need to review some signals and we need to understand what is basically a signal, what is system, what is the role of signal and system in this subject communication engineering. Then we will see कि to do the analysis of signal, we need to represent our signal either in time domain or in frequency domain. Under the same unit, we will also learn which technique is easy for us to analyze the signal, whether it will be a time domain analysis or it will be a frequency domain analysis. After understanding the frequency domain representation of the signals for its analysis, we will discuss the very important aspect of the communication, that is modulation. In the modulation, we will understand why it is required in communication, why it is so important when we are performing communication. What communication is basically, it is the exchange of information from one point to another point. Whenever we want to do this exchange of information from a place to another place that is far away from the source, then we cannot directly send our signals to the faraway point. To make this exchange of information smooth and efficient, we need a process that is called modulation. We will discuss about the modulation in this particular unit in detail. We can also categorize modulation in various categories, that is amplitude modulation, frequency modulation and phase modulation. In the very first unit, we will discuss in detail the very first type of the modulation, that is amplitude modulation. Under amplitude modulation, we have subcategories like DSB, SSB and VSB. DSB is double side modulation, single side modulation is SSB and VSB is vestigial side modulation. After understanding the concept of amplitude modulation, that is the very first kind of modulation, we will discuss the rest two important type of modulation, that is phase and frequency modulation under unit 2. The phase and frequency modulation comes under the category of angle modulation. In the unit 2, we will discuss in detail about these two types of modulation, that is frequency modulation and phase modulation. In the same unit, we will also discuss in detail what are the methods with the help of which we can perform these two kinds of modulation. Basically, we do this modulation at transmitter side. So, at the receiving end, when we are receiving the information, we have to perform the reverse of it also. So, along with modulation, we have to perform demodulation also. So, So, at the receiver side, we need to perform the reverse of modulation, that is called demodulation. In the same unit, we will discuss if we are performing any kind of modulation, that is specifically a phase or frequency modulation, then what are the methods we can extract our original information back from the modulated signal. In the same unit, we will also understand the spectral characteristics of the angle modulated signals. In the third unit, after understanding the concept of amplitude, phase, frequency modulation, how we can demodulate them. Modulation is the process that is to be performed at the transmitting side. We have transmitted our information. Now it will travel in the channel and will receive the destination. At this destination, we need to extract our original information back from the modulated signal. But between transmitter and receiver, there is a path that is called channel that will carry the information. When our signal or when our information is used to travel in this channel, then some unwanted signals used to be added in my information, that is called noise. So, when we are receiving our information at the receiving end, we have to do some kind of analysis. At the transmitting end, what I am sending is a signal, is the useful information. But when my signal or when my information is traveling along the channel, some unwanted signal will also be added in my useful information. So, at the receiving end, what I am getting? I am getting information plus unwanted signal, that is called noise. So, there is the need to do the analysis of the received information plus noise at the receiving end. This analysis is called as noise analysis of the modulated signal. So, in the third unit, we will learn and will understand how we can perform this noise analysis of amplitude modulated signal, phase modulated signal or frequency modulated signal. What is the effect of performing the modulation on the original message? If I am performing amplitude modulation, it will be good for my information, or if I am performing phase or frequency modulation, it will be good for my information. Good in the sense, I will receive more information, less noise, or whatever I am receiving at the receiving, and I should be able to extract my useful information from that combined information and noise signal. Then in the fourth unit, we will discuss some another kind of modulation techniques, that comes under the category of pulse modulation. We can categorize modulation on the basis of signal, that is analog modulation and digital modulation. Under analog modulation, depending on what kind of carrier we are using, we can again categorize analog modulation as continuous wave modulation and pulse modulation. In continuous wave modulation, the carrier we use is generally a sinusoidal waveform, high frequency sinusoidal waveform. In pulse modulation, the carrier is used to be in the form of pulses. So, if we are using pulse signal as a carrier, then it will comes under the category of pulse modulation. So, in the fourth unit, we will understand some more kind of modulation techniques that comes under the category of analog pulse modulation. Under pulse modulation, we will understand the pulse amplitude modulation, pulse chord modulation and pulse width modulation, pulse position modulation. There are some another types of pulse modulation technique. Pulse chord modulation is basically a kind of digital modulation technique. Now, what is the difference between analog and digital modulation? If I am using the information that I want to send another place is in the form of analog signal, then I perform analog modulation. I will prefer analog modulation at the transmitting side. But if my information is in the form of digital data, it will be in the form of 1 or 0, it will be in the form of binary, then I have to perform digital modulation techniques. So, pulse chord modulation is a kind of digital modulation technique. But all the signals that are available in nature that are in the form of analog, temperature, pressure, stress, these all are the signals that are available in the nature, in the natural form, are in analog form. We basically do not have any kind of signal that is present naturally and that is digital in nature. So what I have to do before performing the digital modulation, I have to convert my analog signal into digital signal. While converting analog signal, which is a continuous signal, in a digital signal, there are some steps that I need to be performed. The very first step for converting analog signal into digital signal is sampling, that is this topic. So under sampling process, we'll understand how we can convert or how we can perform the very first step of converting analog signal into the digital signal. After performing the sampling, we have to perform quantization, that is the second step to convert analog signal into digital signal. But that's not enough. After performing sampling and quantization, we also have to do the encoding. After performing the encoding of the quantized data, now I can say my analog signal will be converted into the digital signal. So this all we will understand in unit 4. In unit 4, after understanding the pulse modulation, the concept of sampling, the pulse chord modulation, we'll also learn about some more modulation technique, that is delta modulation, the noise consideration in pulse chord modulation technique, what is the effect of noise if I am using pulse chord modulation as a modulation technique. Then we'll also learn about the multiplexing technique, that is time division multiplexing, and the digital multiplexers that are used to perform the multiplexing. In the last unit, we will learn and will understand the concepts of digital modulation techniques. In the first 2 units, we will be discussing about the analog modulation technique, that is AM, FM and PM. In the 5th unit, we will discuss the digital modulation techniques, that is amplitude shift keying, phase shift keying, frequency shift keying. Basically, what modulation is, there will be a carrier signal, a high frequency carrier signal that will carry my information. The information will is generally a low frequency signal that cannot travel longer distances. So if I want to do the exchange of information that are between source and destination and they are very far from each other, then I need to perform this modulation. So this modulation process will be done with the help of a high frequency carrier signal. This carrier signal will have 3 main parameters, that is amplitude, phase and frequency. So we can basically categorize modulation schemes under these 3 depending on these 3 parameters, that is amplitude, phase and frequency modulation. So while performing digital modulation technique, we can have the same amplitude shift keying, phase shift keying and frequency shift keying to perform the modulation. In the same, we will understand some more digital modulation technique, that is quadrature amplitude modulation, continuous phase modulation and the minimum shift keying. These are the some text reference books that will help you to understand the subject in more detail. That is, the very first book is AKGEC of communication system, the second one is Process, the third book Tobin Schilling is very important to develop the understanding of basics of communication engineering. So let us start with the subject communication engineering. What is communication? what do we understand by the term communication? In day-to-day life we do communication. What is communication? It is nothing, it is just exchange of information from one point to another point. We can define communication in many ways, but the simple definition of communication is just the exchange or conveying of information from one point to a faraway point. What our communication system is? It is a process of conveying information from source to destination. All the components included or all the setup or the system that will help to exchange or to transfer this information from source to destination will make the entire communication system. So, in this particular subject, communication engineering, we are going to understand what is communication, that is the exchange of information from one point to another point. How we can perform this communication if I want to transfer the information from one point to a very far away point, then I cannot directly send my data. I have to do the processing of my information. I have to convert my information in a suitable form that can travel longer distances. So, the complete setup or the components required to complete this exchange of data from one point to another point comes under the category of communication system. Now, I want to perform the communication, that is the exchange of information. What information is? The information can be in the form of sound, it can be in the form of audio signal, it can be in the form of speech signal, it can be in the form of data, it can be in the form of video signal, it can be anything, it can be a picture also. But I cannot directly transfer that data, that picture, that sound signal or that video to a faraway point. I need to convert that data into a suitable form. What signal is? What is the role of signal? Why we need signal? Why we need system? And this communication, what signal is? Signal is a mathematical representation of my data, or we can say what signal is. It is a kind of quantity or entity that will carry the information, that will have some information, and that is variable with respect to time. So, in an electronic communication system, it can be a wired communication system, it can be a wireless communication system. What is the meaning of this wired and wireless communication system? When I am transferring my information from one point to another point, the path or the channel between the source and the transmitter, it can be in the form of wire, it can be a coaxial wire, it can be a cable, it can be a optical fiber cable, it can be a wired medium, or it can be a wireless medium like the mobile phones, like the satellite communication, like the broadcasting. So, it can be anything, it can be a wired medium, it can be a wireless medium. So, in an electronics communication system, whether it will be a wired or wireless, the fundamental entity required to convey the information will be in the form of signal. So, information is transmitted through channel or medium, and that information is transmitted with the help of some signals and with the help of a system. So, what basically a signal? Signal is basically a fundamental quantity of representing some information. It is a function of one or more independent variable that will contain some information. Voltage, current, temperature, pressure, these all are the different kinds of signal. But I need some mathematical representation of those quantities, of those physical signals, so that I can do the analysis of the information that I am sending from source to destination. While receiving the information at the destination, I need to extract the useful information from the information and added noise in my information. So, I need signal to represent my information. So, what I can say, how we can define signal, it is a mathematical representation of the information. Then what is a system? System will be something to which I will apply the input signal, and it will do some kind of processing and will provide the output to me. That processing can be anything, that can be modulation also, that can be amplification also, that can be conversion also. So, system is something that will process my input signal and will provide a suitable form of the signal, that is called the output signal. We can define system also like a mathematical model. It can be a piece of code or software also, it can be a physical device at one end of which I will apply my input, my information, and it will do some kind of processing on that signal and will provide output signal. It can also be defined as a mathematical operator or transformation of the input signal into an output signal. It will process the input signal and produces an output signal in response to the applied data. The input applied to the system is also known as excitation, and the output that I will get from the system is also known as response. So, system is nothing, it can be anything that will process my input signal. So, it is not a single quantity, it will be a combination of so many processing elements. So, we are talking about the signals. We have understood that communication is just the exchange of information from one point to another point. I cannot directly transfer the physical data to a faraway point. So, I need signal to represent my information. That now we can also categorize the types of signal. Depending on what kind of signal I have, I will select the type of communication system, I will select the type of modulation I need to perform. So, depending on the type of signal, there are properties and behavior of the signal. There are basically two main types of signal, that is analog signal and digital signal. What is analog signal? It is nothing, it is a signal that will be in continuous form and that will vary smoothly over time. It can take any value over the given time ranges. What is a digital signal? Digital signal will be a discrete kind of signal, and rather than taking any value, it will take limited value, mainly 0, 1, or it can be a high signal or it can be a low signal. So, analog signal is we can understand like it will be a continuous signal that can take any value. Digital signal will be in the form of discrete signal and it will take limited value over a given period of time. Other than these two types of signal, we can also categorize signals in some more categories like continuous time signal, discrete time signals, that will study. Also, we can differentiate between analog signal and digital signals. Like I have said, key analog signal is what kind of signal? It will be continuous in the form, while the digital signal will be discrete in nature, like this. Analog signal can take any value in the given time duration, it will have infinite range of values, while the digital signals can take limited values of the given time range. It will have finite range of values. Analog signals are more accurate. They will give us more exact values, but they are also difficult to process. They are more sensitive towards the noise, while the digital signals will not give the exact value, but their processing, their transmission and their reception is far easier in comparison of analog signals. So that is why we prefer digitization nowadays. So we need to convert analog signal into digital signal before working with the digital signals. So these are the two main types of signals that we have discussed. In today's lecture, we have seen the syllabus of communication engineering that we are going to cover in our coming video lectures. We have seen what do we mean by communication and what are the basic elements of communication. That's all about this video lecture. In the coming video lecture, we'll discuss some more types of signals and we'll see we'll understand the basic concepts of modulation. Thank you everyone.